Hi, everyone. My name is Frank Lung, Director of Product Management at LookingGlass, responsible for our product and business planning for our threat mitigation product line. I'll be joined by Lee Voltman, Director of Technical Marketing at LookingGlass for this webcast. Today, we're going to outline to you how DNS firewalls enable better network protection from malware, spear phishing, DDoS attacks, and data exfiltration. You'll learn and see a demo that Lee will do later on in the webcast on how leveraging threat intelligence combined with DNS firewalls can move you from finding actionable intelligence to operationalize intelligence and ultimately mitigating threats in an even more automated and informed way. And we will highlight how a fundamental mechanism to connect to and communicate via the internet, DNS, is also a major threat vector that needs to be protected. I'm going to start by saying that the cyber landscape is ever changing and that there's too much threat data, too few humans or technical resources to process that data, which is leading us to too many data breaches. And if we've learned anything so far, is that hackers are becoming more of a threat than ever before. We're going to focus on the DNS threat vector today, and it requires a holistic approach to win this war in this too much, too few, too many cyber landscape. And when we say threat data, let me try to clarify that it's not the same as threat intelligence, and which we will cover in some level today in this webcast at all. But at LookingGlass, we believe that it takes subject matter experts with years of experience and in many cases formal training to interpret the massive amount of data that is available and determine what the few nuggets of actionable information is relevant to an organization, at which point it becomes intelligence. To add some more context to this, Internet Live Stats and some other estimates that are over 200 million active websites out there. DNS is everything Internet, and it's constantly growing. And since standard security measures do not block DNS traffic, cybercriminals are able to infiltrate networks and gain access to your data. In addition to launching attacks, cybercriminals can also exploit an organization's DNS to cause outages. Something also to note is it's also estimated around 75% of these websites, 75% of websites today are not active. By what I mean by is parked domains or similar. So registered websites are closer to registered websites or unique host names out there are closer to 1 billion websites. Speaking of billions, Cisco also estimates the number of devices connected to the internet will swell from 10 billion today to over 20 billion by 2020. So again, more websites, more data, more phones, tablets, connected cars, watches, trains, planes, what have you, things. All more and more dependent on this 3-letter acronym that we call DNS. And DNS is a major attack vector that many organizations don't pay much attention to. Again, a Cisco study, almost 68% of organizations don't even monitor the recursive DNS. So why are we talking about DNS? As mentioned, DNS protocol is largely unprotected and indeed your Achilles heel. As noted by an internet inventor, not named Al Gore, once said. You may be familiar with headlines like these that have hurt some prominent brands. These DNS attacks in the form of DDoS that flood a network to subversive advanced persistent threats, APTs, buried inside a network that export information via your DNS. Cybercriminals who aim to take down your business and damage your brand reputations are betting on the fact that you will continue to ignore one of the most vulnerable, and essential piece of your infrastructure. DNS is a threat vector that is often ignored in favor of other sexy technologies like appliance-level firewalls or perimeter-focused security appliances. DNS is important particularly for recursive DNS. Again, we're going to double-click on this in the subsequent slides here, because every transaction between systems across the internet, with a few exceptions, whether malicious or otherwise, requires DNS resolution. So organizations can control the traffic on their network simply by focusing and securing this threat vector. Important point here is the paradigm for organizations is now to assume your network is always compromised. This means current technologies are not working, and DNS gains even greater emphasis as a means to protect and secure your network. Here's a case in point with a recent security flaw called Firestorm. The Firestorm vulnerability works by forging messages and tunneling them to a command and control server during the TCP handshake process, bypassing the firewalls to any destination on the internet, regardless of the firewall rules and client restrictions. Because next-gen firewalls allow this handshake to complete prior to any enforcing policy, there's a window where information can be exfiltrated over that connection. There's a way to close that gap, this dangerous gap. What if the compromised host was never allowed to contact the C2 server? Even better, what if the compromised host didn't even know how to contact the C2 server? The infected host or malicious software would never have the opportunity to establish a connection that data could flow over. This is exactly how a DNS firewall placed between an internal network host and the organization's recursive DNS server protects an organization from malware, spear phishing, and unauthorized data exfiltration. Almost all connections that occur over the internet begin with a DNS resolution, request by the client to retrieve IP addresses of the server that is trying to reach it. DNS firewall, like LookingGlass DNS Defender, can intercept the DNS resolution request from a compromised host asking for the C2 server's IP address and either blocks the DNS request or redirects it to an internal sinkhole or some other safe location. The infected host never receives the IP address required to contact the C2 server, which means the TCP handshake never begins. The vulnerability is mitigated through the use of a DNS firewall. Again, we're going to touch on the C2 DNS resolution in some later slides here. So the question to ask yourself is, what are you willing to risk? General Michael Hayden, former director of NSA and CIA, says the classic risk equation is risk equals threat times vulnerability times consequences. Multiply those threats, attacks, your vulnerability to attack, and the losses or consequences from attack, and you will see that your risk is quite high. Organizations have a lot to lose if your infrastructure goes down. These losses are painful and costly, loss of transactions, the loss of revenues, all the way down to loss of data, putting your customers' privacy and security at risk and in danger. And once you get through attack, how will you deal with those aftermath? I mean, those are the consequences that we need to consider. So let's double click on how we can help. Let's do a quick DNS 101. A bit of an eye chart here, but hopefully I can walk you through it. When an internal enterprise host attempts to connect to a website from a browser, the URL resolution is sent to the local recursive DNS server. If that server doesn't have information on that URL, then it sends it out to the global internet, starting at the root server, then to the .com top level server, and then finally the example.com server. Once the IP is cached in the recursive DNS server, the IP can be provided by the local recursive server. First premise is that malware is always going to get into your enterprise and your network. In this case, the malware looks for the command and control server or the C2 server, ending with the domain bad.com. It follows the same behavior as a normal application to resolve the IP. Now, let's look at the flow. When a DNS protection system like DNS Defender or DNS Firewall is deployed, it's mostly the same topology as before, but with one additional system in the path between the enterprise network and the recursive DNS system. In this case, your SecOps admin has previously learned about bad.com and decides to block that domain. When the malware attempts to connect to the C2 server, the initial connection is immediately blocked by DNS Defender, and therefore the malware never learns how to communicate to the botnet C2 or where to send data to. The event block is still logged by the SIM, assuming that you have one, so that the SecOps admin can be notified that the laptop is infected, and they can track down the laptop to remediate, or a desktop or client. Now, this example shows the basic workflow if threat intelligence was somehow learned by SecOps. But what if you have thousands of rules and thousands of domains? So with a threat intelligence system deployed, SecOps can start to automate the rule deployment based on thresholds and rules that are predefined for your environment. That way, SecOps don't have to manually provision the rules. It's automated. It's where it comes in handy when you have tens of thousands of rules to manage. So finally, threat mitigation for DNS does not need to be based on just blocking. One can also rate limit or slow down traffic, useful in case of DNS DDoS attacks or additional analysis of traffic, or just redirect it, as we kind of pointed out before. Now, let's talk about the impact of attacking DNS. I'm going to hand this over to Lee. Lee will now talk about the types of DNS attacks and the impact it has with it. Lee?
Thanks, Frank. So hi, guys. Thanks for having me on. Lee Worthman, Director of Technical Marketing. So I'm going to cover a couple of things with you. First, I want to start with an overview of what DNS attacks security operations have to deal with. And I think this is important to understand because as we talk about the DNS infrastructure and we talk about the capabilities that DNS Defender can handle, I think it's important to understand the different types of attacks that we would need to address with this type of mitigation technique. So really, there's two types of broad categories that you'll see within a DNS attack. You can see there's denial of service attacks, which is attempting to disrupt or prevent access to a legitimate service, in this case, DNS. If we can't resolve DNS, then our organization can't make that basic communication across the internet or our networks, and then we can't conduct our normal business transactions that we're trying to do, as Frank covered earlier. And the second type of attack is really broken down into DNS protocols and server vulnerabilities. And this really comes into attacking the protocol itself, attacking the services that DNS is trying to provide. And again, this can also really be the start of a denial of service attack, depending on how the service is going to respond. But really what you're trying to do here is crash that service, bring it down, maybe do some sort of remote code execution. You're really trying to, break that service so that it can't respond, and or maybe, try and use it as a foothold or a toehold to get into the network. So I just wanted to cover a few of these specific types of attacks just so we're familiar with them. First being the DNS flood attack, right? So we're going back to the denial of service attack. So a DNS flood attack, basically an attacker is, flooding one or more of your DNS servers with tons and tons of UDP requests, and really they're attempting to exhaust the resources of those DNS servers. The DNS server only has so many, resources to respond to these queries, and if they're getting just a ton from one source or maybe multiple sources, that's going to cause the server to stop responding or just try and address that one illegitimate source, and therefore they can't get to the people that need to actually be able to get the DNS resolution. So similar to that is a DNS amplification attack. So in this case, though, they're using a spoofed IP address and the attackers are using the spoofed IP address and sending that to a DNS server that's open. In this case, they're able to pass DNS requests through that. The responses, because they're spoofed, are sent to the victim, right? So you spoof the victim's IP address. The responses, the requests go to the DNS server that's open. The responses go to your victim, and essentially you can just flood that victim with tons and tons of queries, right? Taking their DNS servers offline. And so, if you were a business, let's say like a large web transaction business, for example, and you couldn't actually have your clients resolve your website, then obviously you're not going to conduct those transactions. Reflection attack, similar to amplification attack. In this case, the attacker is sending DNS queries to a vulnerable DNS server using a spoofed IP again, but the responses are sent to the victim, causing a denial of service. So in this case, there's not necessarily an amplification like before where you're sending one to many. This is more like a one-to-one, but the same type of attack as the amplification attack. And then distributed DNS reflection attack. So essentially you're using multiple host machines caused by controlled by the attacker, and they're distributed around the internet, and you're having all of those at once, send everything to a single source, distributed DNS attack, and you're basically trying to, again, cause a denial of service and bring that down. So moving on to the protocol and server vulnerabilities, other things that you could encounter as a security professional with your DNS infrastructure is oversized packets, right? So someone sends something and the server is expecting a certain number of bytes in that packet. We exceed that byte limit, and it can cause a buffer overflow. It can cause the DNS server to respond unpredictably, and essentially this is something that the DNS service can't always respond to appropriately. There's actually just a recent there was a recent vulnerability found by Google actually about a UDP oversized packet that could send and essentially crash the DNS service or lead to remote code execution. So this is still very, very relevant for organizations in terms of what they're facing today. Unexpected header, again, you're sending a packet with some sort of unexpected type in the actual packet, in this case, an unexpected header. The DNS service can respond unpredictably or crash. Malformed packets, same thing. You're basically just trying to, send all sorts of weird flags or weird bytes into the packet and essentially, again, try that to crash that service. Fragmentation attacks, you're trying to split up the packets, right, into different fragmentation rules and causing the server to have to try and reassemble these in different ways and use as many resources as possible to try and get these things back together. And again, similar to a denial of service attack, if you do this enough, right, eventually the DNS server can stop responding or become unavailable. And then lastly, kind of a favorite for attackers, right, is a cache poisoning or poison pill, right? If you can place a fake DNS record in the cache of your target, for example, so if I were able to place a fake DNS record for my malicious website or my malicious botnet command and control server in the target DNS cache with a legitimate URL that resolves to it, when my victims try and go browse to that legitimate URL, they'll instead go to my malicious domain. And therefore I can exploit them in some way. So, right, these are all the different types of attacks, that we can begin to try and understand and address with a DNS firewall. Now I want to give you an example. So next slide, please. Let's talk about an example of an actual customer that we've had at LookingGlass. So, I want to share the story about a security issue that one of our customers experienced, and this particular customer happens to be one of the largest ISPs in Central Asia, and their DNS environment. You can see on the slide, the architecture has two locations, one north and one in the south. And, really this was just set up for redundancy. Each location was equipped with a border firewall, so they had a typical perimeter firewall that they felt was sufficient, and they had two DNS servers. Next slide, please. So the ISP thought that their existing firewalls would prevent, a large-scale outage, would protect them from this type of attack. But as we'll see, right, the firewalls are very, very good at filtering protocols that are legitimate, right? You can allow or deny the protocols that you want. But once you allow or deny those, it really doesn't know whether or not the things that are happening with that protocol, right? Are you going to a web server? Yes, I'm allowing port 80 HTTP. It doesn't really care whether or not that web server is legitimate or not. And so we can see in this case, right, the ISP thought that their existing firewalls would prevent a large-scale outage, but they began experiencing a denial of service and cache poisoning attacks on an ongoing basis, and their normal perimeter firewalls were not protecting that DNS infrastructure, and so they actually suffered an attack that took out all of their DNS servers. And to kind of give you an idea of the scope, all of their customers were without service for approximately 6 hours. And so I don't know about you, but if my ISP was down for 6 hours, I wouldn't be able to go to work or conduct business or go shopping online, which would be very agonizing for myself. So in this case, right, it included their 2,100 multinational corporations and more than 800 global, regional, and domestic carriers. So this was a fairly substantial and significant outage. I can only imagine how much revenue they lost because of that. Next slide, please. So let's talk about the benefits of DNS protection. How could this have been prevented? So DNS Defender, in this case, was installed in the north location, and it immediately stopped the DDoS attack and the poison pills attacks that were taking down the servers. And it also prevented the cache poisoning. So essentially, the moral of the story is that the DNS vulnerabilities that were taking place in this case for the customer or potentially your business aren't necessarily and probably aren't going to be mitigated by your next gen application level firewall or your perimeter firewall. You really need to have a specific protocol level DNS firewall like DNS Defender that you can put in place to begin to, as Frank discussed, right, rate limit, block, filter out these malicious protocols, filter out some of these attacks, and really, in this case with this customer, you'll see that it was able to pay for itself after identifying and stopping the first attack. Get this ISP back up online, get them able to resolve DNS for their customers, and be able to conduct business again. So that's my example. I will revisit you guys again when I cover a demo, but I'm going to turn it back over to Frank to cover a little bit more about threat intelligence systems and key elements.
All right, thank you, Lee. Great examples. Again, I'm going to jump into paint a story for threat intelligence system key elements, but before we start on that, I want to level set on a couple of terms that's probably overused, but just want to make sure that we have the common taxonomy in place. You've heard us use these terms, but it's important to again, to level set where we are. Threat intelligence, right? Again, I think in the beginning of the slides we said it's evidence-based knowledge, right, including context mechanism, indicators that can be used for informed decisions. And then another term that we've also used in previous slides here is threat mitigation. It's really the the basis of what LookingGlass sees is that it's an elimination or reduction of the frequency of risk or exposures. Okay, so now we have that out of the way. Now let's start by working through a use case that we're going to progressively build layers upon layers of features on. So again, first key elements, what we'll call the global threat intelligence system that essentially collects, correlates, provide analysis, and then prioritize. First step in our journey is to monitor that global internet topology in real time for active or emerging threats that are occurring. We do that in multiple ways. We combine our open source and third-party proprietary feeds with our own Glimmer HoneyNet network and our own in-house threat research group. And again, we've talked about it as Intel is really it's resource-based, and overlay that information on top of the global internet topology. This allows us to identify the external threats and map them against your organization's advertised networks. Now, two, we give you an easy-to-understand threat score, and we expose every aspect of those, arrive at the score so you could trust and also verify how we arrive at that information, and that it's relevant and makes sense to you. Three, we give you the ability to modify or change the scoring based on your specific organization's requirement. Say you want a new domain that shows up in the last 7 days and weight it more heavily in the overall threat score. Easy enough, we could change that in our system. And then four, we built our system for web scale. So our solution is built on an architectural foundations, both hardware and software, that's seamlessly scales out no matter how large the data sets, how many observables or elements. All you do is add, out of Blade, and Scout Vision will automatically rebalance across the available compute and storage and network resources. And lastly, we're delivering real-time streaming updates based on the most updated data info. If the network topology changes, you'll see it. A new URL shows up, you'll see it. Corporate credentials shows up on an underground forum somewhere, you'll see it. And we make it all available to you in real time. Now that we know everything in that is occurring outside of our perimeter organization, correlating that with what is occurring inside your perimeter is how we provide the context required to determine the threat that's relevant to you. NetFlow and snort-based signature matching correlated with threat intelligence is our second step in this journey to transform this information. We have a product called Scout Intersect Platform, which Lee will also provide some information on in the demo later. It correlates NetFlow information into a stored system for historical and real-time analysis. You can generate reports ad hoc or be scheduled, and you have ability to export those reports into PDFs or CSV formats. Now, the final step in our use case is to leverage the LookingGlass appliance, which is my product, the mitigation appliance, to deliver threat mitigation. A DNS Defender, as mentioned, is our DNS DDoS and DNS protocol-specific firewall. Many times, the first thing an exploit or a bot will do after waking up will be to phone home to their C2 servers, as we mentioned. The phone home traverses almost always go through DNS resolve the URL with an IP address. Now, using DNS Defender, we're able to protect against many types of DNS DDoS attacks, as Lee had mentioned, and as we configure firewall rules, either whitelist, blacklist, to restrict access to specific IPs or block IPs. But DNS Defender, noted, is not just a security appliance, it's also a load balancer with fast cache repository that increases the number of DNS requests your existing infrastructure can handle and decreases the latency of those responses. So as we described, there are lots of uses for environment security ops. So instance response or security ops. What we're going to focus on, two primary areas. It's network security and security operations, and show how DNS protection leveraging threat intelligence could benefit. And what at LookingGlass we call this our dynamic threat defense. By integrating DNS Firewall like DNS Defender with machine-readable threat intelligence like what we can deliver in LookingGlass Scout Vision, or surveillance, phishing, or malicious URL data feeds, the DNS Firewall is constantly kept up to date with the latest malicious domains and IP address and APTs and botnet C2 servers controlling the infected hosts and malware residents on corporate networks. So we're going to get into, I'm going to transition this to Lee to demonstrate what this looks like in our live environment. Lee, I'll hand this over to you.
Thanks, Frank. Just going to get my screen set up here, and then I will share some great stuff with you guys. Okay, so what I want to show you guys is basically how we at LookingGlass execute on the things we just told you in the presentation. So essentially, how do we find and consume the threat intelligence? How do we correlate that with the understanding of the global internet topology as well as internal network traffic for a specific organization? And really what we want to do is get to some piece of threat intelligence that's actionable, and then be able to use our platform Scout Vision that you see here as a policy definition engine. So if I find something that is impacting my organization, whether it's on my external network presence or it's from a host internal to my network that may be infected with a piece of malware and beaconing out to a command and control server, I want to be able to have a one-stop shop to go in and define a policy that will be pushed down to, in this case, DNS Defender as a policy that will mitigate that threat for me within, a minute or two, right? So very, very quick. And as you'll show, as we'll go through the demo, I'm going to show you where this will become even more automated in terms of once you find, for example, I'll show you an infected host here in a minute that has 420 different malicious domains associated with it. There's another one that I'll show you that has like 31,000 associated with it. And when we come back to the concept that perimeter firewalls or your next-gen firewall is not going to be sufficient to protect these threats, consider how long it would take you as the administrator of those firewalls, or maybe if you're not that administrator, maybe your organization, that you identify these threats and you have to go in and update these security appliances. I mean, how long is it going to take for that to take effect, to input 31,000 different malicious domains to be able to block just that one threat, right? There may be 100 other threats that may have another 30,000 domains associated with it, and that becomes, unmanageable, right? Unwieldy. So what we're going to show here is, again, going in, finding threat intelligence, finding that correlation with the things that we're concerned about that we own, finding actionable intelligence, whether it's external or on our internal network, and then taking some action and mitigating that threat. So I'm going to orient you with Scout Vision to show you how it works, and then we'll get into an example. So Scout Vision is essentially broken up into projects. These projects are designed to allow individual security operations administrators or professionals to have their own area that they might be doing monitoring or research, or for maybe an analyst that wants to investigate different threats. And essentially the way this works is, I'll just pick our example of a large company here, is that it's all keyword based, and you can go in and essentially find the internet-facing resources that are associated with that company, right? In this case, we can find all of the autonomous systems. We can also go in and find any CIDRs that would be associated with this. And in some cases, right, you can also find pieces of threat intelligence that may have the keyword of that company or keyword that you searched for in the name, right? So you may be able to find specific threat intelligence that is targeting that company. In this case, you see a couple that are coming up here. So very, very quickly, we're able to find the resources that we are concerned about, that we want to either understand if there's a threat associated with that, and be able to find that threat intelligence to be able to take action on. So I'm just going to do a quick example here to show you how this works in terms of essentially the way we do this, the way that you want to group or cast a net around pieces of information to begin monitoring them, is we have this concept called tagging something. In this case, I'm just going to tag it for webcast demo. And we're going to select a couple of these ASNs. We'll select Amazon in Ireland and there, and we'll just save these tags. And then we'll select a couple of these as well down for CIDRs, just to give it some variety. And essentially, once we do this, we're casting that net, right? We're grouping this information together to allow the Scout Vision to essentially monitor these things. And so once I've tagged that, if I come up here, just refresh my browser because it's going over a VPN connection, and I apologize, it's a little slow. So once we essentially have that, we'll be able to go in and look at those network resources and those elements to essentially be able to look at, we'll see the intersection, the correlation of those network elements and any pieces of threat intelligence that it's found. So we'll just give this a second to come up. That was a very large ASN that I just tagged. And so we'll look at the webcast demo now for these ASNs. And when we drill into this, we look at these items, we see these autonomous systems that I've tagged. And so now the question is, okay, I'm monitoring these autonomous systems, I'm monitoring these network elements. How can I see the intersection, right, of these threats, right? And then maybe there's some hosts on these ASNs that are affected with malware that may be, or maybe serving up botnet command and control servers. And so what we can do is when we look at these inherited tags, this is the intersection, the Venn diagram of network topology, global internet topology with threat intelligence. And the intersection here you see is these are pieces of threat intelligence that are, once this comes up, essentially network information directly associated with the owner, in this case, Amazon, that I searched for, and we can go in and actually investigate and look at what these hosts are. So in this case, right, something that's brute forcing SSH, we can look at this individual host and see what that is. Something is associated with this hacker website, right? We can go in and look at, and interesting enough, right, these are all part of the same site, right? So we can go in and begin to investigate these things. And so if I click on this host, right, I can now see, I can identify that, this is, clearly hosted by Amazon. It's been associated with a threat. That score that Frank was talking about, that criticality score right here. So this is a criticality score of 60 is fairly elevated and something that would be a pretty significant risk for this organization. We can see a lot of other information about it, such as the geolocation. In this case, it doesn't have a DNS history, but I'm going to show you a different example that does. This was just one that I pulled up on the fly, but you can see that we get a lot of information about this host to be able to make a risk assessment of whether or not this is something that we want to mitigate. And to give you an example of how we might mitigate this, I'll show you in a second, but it's exactly the same way as I tag these network elements. Is we're going to add a tag to these network elements, and that tag is going to get pulled down into the DNS Defender and take the appropriate action. So this is a specific threat that we've associated with an external host. This could be, a web server that Amazon is hosting. It could be something in AWS. Again, this would be something that the Security Operations Center would definitely want to address. Let's take a look at how we can correlate internal threats with the Scout Vision to see, again, if you were a customer or if we were wanting to understand our own networks, in this case, our demo network. We can take a look at the malicious traffic that's flowing across that network by taking we can essentially collect net flow, and we can take that net flow and import it into the tool, and Scout Vision will take that net flow, look at the source and destinations of where it's going, and will do the same correlation. So give you an idea of what are my internal hosts doing, right? I have an external picture. I'm able to monitor that. I'm able to see what those threats are. And we've already shown that through the ASNs, insiders, and the hosts there. But I want to see what my internal network is doing. And this comes back to relevance when you heard Frank talk about the recursive DNS servers, right? It's going to be much more impactful for the security of an organization if you can protect your recursive DNS servers. And one of the best ways to do that, right, is to understand what traffic is egressing your network. And what I'm going to show you here is Scout Vision. Is Scout Intersect, and Scout Intersect is essentially this add-on functionality to Scout Vision that lets you take that correlation of net flow records and begin to understand what threats are actually on your internal network. So to give you an idea of how this works, essentially we can do a couple of different things, right? So we can create an ad hoc report, which I'm going to show you how to do this here. And what's interesting is we can choose the time frame, right? So if you're an organization and you're collecting net flow records constantly, and maybe you have 90 days or 180 days of net flow records, if those are imported into the system, you can go back to that time frame, and this will become relevant, right? As if you're an organization, you are maybe just detecting a unique form of an attack or a unique piece of malware, and you want to go back in time and see whether or not that piece of malware existed on your network 90 days ago, for example. You could target this report to be specific to that time frame of 90 days ago, or you could just generate a report daily. Really, it's up to you how you want to actually target this. The other thing you can do is you can choose to set the indicators to either be historical, meaning these are indicators that were active 90 days ago, for example, or you can set the indicators to be active for now, right? So for example, again, the example, if you discovered a unique piece of malware that no one else had identified before, and we just got that piece of threat intelligence into the system today, and you wanted to see if you were infected 90 days ago, you could set those indicators to go back and see, yes, I was actually infected 90 days ago. I need to go and do a bunch of remediation. So what does this look like once we get this report generated? And this is where you can see we essentially have what we call telemetry, network information for, again, whatever subnet, whatever NetFlow records that you are going to import here. So we see the tags. These are essentially direct correlations of threat intelligence that we see with those NetFlow records. And then we have source and destination, again, source and destination IPs for those NetFlow records as well. What we can do is not only sort by tag count, which is what I'm sorting here, right? So this would show you the most active pieces of threat intelligence that are associated with your NetFlow, but we can sort by bytes. And this is where I find it gets interesting because, again, going back to the example of DNS, if someone has infiltrated your network or a botnet, malware has infiltrated your network and is communicating to a botnet, right? Most likely they're not just there to communicate back and forth, right? They want to steal your intellectual property, they want to steal credit card records, they want to steal, user account records, customer information, whatever they're going to be doing, and they're going to be transmitting information back and forth. And when we can sort this by the number of bytes that are transmitted, that's where I find it gets really interesting to begin to understand and make an assessment of the risk. So what I just did here was I sorted by bytes and I clicked on this particular threat tag, which is serving executables, right? In this case, this will lend itself nicely to show malware. And again, if I come down and look at these, this specific telemetry, I sort by the size of megabytes transmitted, we can begin to see some interesting things. In this case, if I open this one up, and I'll show you what this looks like here, this is essentially a infected external host, right, that we've observed through our NetFlow records. Someone internal to our network was communicating with this malicious external host, clearly identified as a malware command and control server. And the reason this is taking so long to process this DNS history is because there's 31,000 records associated with this one host, right? So when we get into the concept of domain generation algorithms, right, basically the ability to try and just rotate through as many domains as possible to play leapfrog and try and avoid getting blocked or detection, this is a prime example of that. And I'll come back to this one in a minute as it loads, but this is a good example of that, of one of those malicious hosts essentially serving up malware. And I'll open up this smaller one here to give you an example of what it looks like. This one should load a little bit faster. And you see this is also a command and control server, but this is what the DNS records look like. And so, again, as Frank and I are talking about DNS as an attack vector, imagine trying to put, let's just look down here. Imagine trying to put 428 entries into your firewall just for this one host to, protect against this threat. It becomes, again, cumbersome. So how can we automate this mitigation process? And essentially, we're going to add a tag, right? So if I wanted to tag every single one of these domains I've clearly associated as being a threat, as someone internal to my network is infected with malware, they're communicating with an external botnet command and control server, and I want to go through and make sure I mitigate every single domain that is associated with that server, what we're going to do is we're just going to go in and add a tag. In this case, we have a demo tag, and again, recall, as Frank discussed, the DNS Defender, right, we can redirect. So in this case, I'm going to redirect to a safe site, in this case, a site of my choosing. This could be a honeypot we have internally. It could be an internal IT system. In this case, I'm just going to redirect it to a fake web page, which I'll show you in a second here. But we could also block, and we could also rate limit it, right? So if you have a threat research team that may want to understand that threat and rate limit it to mitigate, to minimize the threat of communication back and forth, that could be something as well. Or you could just go and outright block it. So in this case, I'm going to redirect, and essentially what will happen is all of these domains and any communication with these domains, right, at the DNS level will essentially be redirected to a site of our choosing. And let me show you now exactly how that is going to work. So what I have here is this is our demo fake malicious website. Essentially, this is indicative of a botnet command and control server or a site serving up a watering hole attack. Again, some sort of malicious site that we want to mitigate. In this case, we have it as bad lgscout.demob. And what I want you to pay attention here is both the IP address as well as the URL. And if you recall, Frank talked about how essentially we, when we do the redirection, right, we're trying to disrupt or get in line of the DNS, responses here, and that's exactly what we're going to do. And I'm going to do that through the interface of Scout Vision. So essentially, I'm going to search for that domain, and make sure I'm in the correct project. So I'm going to search for this domain, and it's going to come up, and in this case, I've tagged it with Saudi, just as an example, right? It could be really anything. As you saw, some of the other tags that I pulled up for hosts, right? Malicious command and control servers, things like that. But we're just going to add a tag, and we're going to add the tag for demo to redirect, and we're going to have that take effect. In this case, it's already applied. We'll just remove it, and we'll re-add it. And so essentially what this is going to do now, I'll just refresh my browser here, is, and this takes about a minute or two, and while this takes effect, I'm going to talk about it. But what you'll see is this will automatically refresh to a, eventually the page will turn green, indicating that we're now being redirected to a safe site, right? And so we're essentially mitigating those threats, right? So coming back to this example, right, where we have, in this, right, this is the one with 31,000, right? So if I wanted to essentially tag all of these, right, again, I would go in and essentially select all of the DNS history and tag it to essentially, block, or, in this case, I can drop it, right? But I would block all of these malicious domain servers to be able to mitigate that threat. So, so that's essentially what we're going to be doing while this takes effect. The DNS Defender in our demo environment, and similar to a typical customer deployment, is actually sitting in line to our recursive DNS servers, and basically it's going to be the one that handles the requests and responses depending on the rule sets that we've set. In this case, we're going to redirect those sites. So while this is taking a moment to, I'll come back to this just to check on it, but while this is it takes about 2 minutes to take effect, I wanted to show you one other thing, just to give you an example of the scope of the problem that it is to actually be able to mitigate and block DNS websites, for example, right, without some sort of automated solution like we're showing you here. And so if I do a quick search for DTD, we have a couple blacklists that we've actually set up as part of threat intelligence feeds that we have. And I know Frank covered this a little bit, but essentially we have sinkholes, right, that are looking for communications with malicious sites, botnet command and control servers, and malware communicating back and forth. And we're able to distill that threat intelligence down into different feeds, right? And so in this case, this DTD all is everything that we are seeing malicious. And to give you an example of the scope of this, right, it's not 31,000 like that one clearly malicious host, but still these are the top 15,000, give or take, known malicious domains, right, that we have associated clearly with some sort of malicious communications. And so again, right, identifying all of these and trying to put them in your firewall manually, right, would be a very, very cumbersome process without some sort of automation like we're showing you here. So the ability to tag these 15,000 or have these 15,000, for example, automatically come into your firewall like DNS Defender, automatically block the known top 15,000 malicious domains that are being used actively in malware like Saudi and Flame and other malware that's still being seen out there. I think is a very, very powerful and very efficient way, right, to be able to protect your organization. So while we were talking, notice that my redirect rule took effect. The page is a lovely green just to show the example, but notice the IP address changed, right? It changed from 122 to 121, but notice what happened up in our browser here. Our URL stayed the same, right? So DNS Defender is sitting in line, and it is actually responding to the queries with a manipulated response, right, UDP protocol to actually redirect us to this known good site. But my browser still thinks, obviously TCP, still thinks that I'm going to the bad site. And again, this would be a prime example of how you would mitigate those threats that your customers, or you as your organization, right, you as your internal network traffic, for example, your infected users on your network, you could essentially go back and mitigate those threats very, very quickly. Again, simply by defining a tag, right, defining a rule within Scout Vision and blocking every single one of those malicious threats that you've seen. So just to give you an example, right, this is some statistics we have for DNS Defender to show you that it's working. You can see a bunch of other information there. But to bring it back full scale, just to summarize, okay, so what we've done within Scout Vision, relating it to the webcast, so we want to be able to block and mitigate these threats at the DNS level, right? We've gone into Scout Vision, our platform for threat intelligence management. We have roughly 140 different feeds coming in here, a variety of open source and proprietary. We have correlated that information with network topology. We've searched that information for things that are relevant to us. We've found things that are actionable that have been correlated with threat intelligence. And we've gone in, whether it's internal network traffic via Scout intersect in the net flow, or it's external hosts, right, that we are seeing that are infected somehow as well, like somehow conducting malicious traffic. We're able to simply go through with a tag that in Scout Vision, define a policy, have it go down into DNS Defender, and block anywhere from 1 to thousands of malicious domains that we clearly want to mitigate. So with that, I will turn it back over to Frank, and I'll let him wrap up, and then we will go into some questions and answers.
Awesome, Lee. Smooth as always. Yeah, as Lee mentioned, and I think he already did a great summary of what the kind of the purpose of the webcast. But again, just to hit on some of the key points here, is that we discussed why DNS, a fundamental mechanism to connect to the internet, is an important threat vector that that needs to be protected from malware that communicates with the C2 server, where inspections can provide early warning to your SecOps team and how the integration of threat intelligence with the DNS firewall like DNS Defender can help provide a focused and automated mitigation of these threats. And then finally, by controlling DNS both internally and externally, organizations can protect themselves from threats that are, missed by next-gen firewalls and what have you, and other popular security appliances. Again, hopefully this shines a light on another tool for your tool chest to this ever-changing cyber landscape that we live in today. And as Lee mentioned, I think we have some questions that we've brought in, and so maybe I'll try to tackle some of them up front here. And I'll leave this kind of our contact information and the LookingGlass Advantage slides up while we address them. So the first question that we see here is, do we still need firewalls and antivirus? Can we get rid of them? So this is a pretty popular question. Kind of as mentioned in my summary, it's really, DNS firewall is another a tool in your tool chest, right? While, the existing defense can't stop every attack and nothing can, they're still useful and critical, right? So threat never expires, and every piece of malware ever created is still circulating out there. So, signature-based solutions are still required at, preventing known threats from infecting your system, no matter, which vector they arrive from. But customers should have, best practice of updating their DNS software, firewalls, IPS, IDS, and again, looking at all the tools available to, address the malicious act, right, towards your organization and your network. Another one here is, we're planning to outsource all IT. Does this still matter? Well, I think it's probably a personal company enterprise preference, but your company is probably looking at outsourcing email or archive or other storage needs, or maybe even some applications, but probably not outsourcing your network, which ties users to outsource resources. So your network is likely included in other recursive servers that can be optimized or protected. So again, your IT operations team will need to look at it and decide what's the best course of action. And you'll likely, discover that there's still other areas that you may want to look at and protect. So yes, we believe it's still it's a likely scenario that applies. Here's another one. What threat intelligence is Scout Vision managing? So I think you've already touched on that a little bit, Lee. I'll let you address this one.
Sure. So Scout Vision, we essentially have roughly 140 different feeds that we bring into the platform to do the correlation. There's a mixture of open source, our own proprietary feeds that we have, as well as what we consider to be premium feeds, which are feeds that you can subscribe through to us if you would like to, or if you have your own subscription, you can bring them into the platform. The platform is flexible enough that if you have your own custom feed or your own premium feed, you can bring those into the platform as well. So we have a number that we provide for the platform to do the threat intelligence that you saw me demonstrate here, and then you can certainly bring in your own if you would choose to, or subscribe to premium ones there as well. So, you know, to give you an example of the number of pieces of threat intelligence that come into the platform through those 140 different feeds, we see roughly on the order of maybe 6 to 10 million unique pieces of threat intelligence come into the platform through those different feeds. And, you know, a human can only look at, I think, you know, a couple hundred to maybe a couple thousand, right? So having some sort of automated way to understand the risk and correlate those with the network resources that are concerning to you, right, and being able to mitigate those is in as automated a way as possible, I think is very important to the organization.
Okay. I think there's another outsource question. What if we just outsource our DNS? You want to talk?
Yeah, I'll take that one. Yeah, so, you know, it's certainly an option, right? You know, that's certainly an option that you can choose as an organization. I think you need to make sure you understand what you're trying to accomplish there, right? Because there's some trade-offs that you have. You know, as we've shown you here, having control over the DNS that is leaving your network, being able to control what's actually hitting your recursive DNS servers, being able to control what hits your authoritative DNS servers, and having control over that and being able to choose the action that you want, I think is very, very powerful when it's also associated with threat intelligence. I think outsourcing it, you lose a lot of that functionality in terms of, you know, what threats am I seeing? What am I being targeted by? You know, what threat intelligence maybe maybe that I'm seeing that is also correlated with other attacks that I'm seeing, such as physical or maybe brand attacks that may be correlated. And if you don't have that threat vector as a source, right, you're going to be losing that. You know, other operational considerations for outsourcing your DNS are, you know, you essentially have to send that traffic over to a third party, right? So, you know, you're having to somehow securely, or in some cases unsecurely, right, send over all of your recursive or maybe authoritative DNS traffic to that third party and hope that that third party is secure, right? So again, you're losing control of this. You're using up additional bandwidth. You're possibly introducing delay into the network. You know, so, you know, I'm not saying it's not an option. I just think that there's a lot that an organization needs to consider and needs to balance those risks with that choice of, do we outsource or do we keep control of the DNS and maybe put a solution in place that can mitigate the threats we're seeing.
Okay. I'm going to give this one to you too, Lee. It says, why do we need a DNS firewall? Can't my current firewall, next-gen firewall, prevent these threats?
Yeah, so we talked about a little bit this a little bit previously in the presentation, and I covered it a little bit in the demo. But you know, your standard firewalls at the perimeter, and we covered this right in the customer use case, right? The standard firewalls at the perimeter and your next-gen firewalls, they have a specific use case, right? You need to protect your perimeter. There are low-hanging fruit attacks that you need to protect against. Your next-gen firewalls are protecting your applications. That's great, right? But both of those, right, they have specific use cases. There's filtering out specific things. They're allowing specific things, right? And as I covered before, right, your standard firewalls are basically allow or deny a specific protocol, right? And once you allow that protocol, pretty much anything goes within that protocol, right? So you need a way to filter at the protocol level, in this case, specifically at the DNS level, and neither your standard firewall or your next-gen firewall is going to have that capability to be able to block that threat. So I think it definitely is an area, a threat vector that's often overlooked, and I think it's one that, you know, we're obviously advocating customers to take a closer look at and you know, consider it a threat vector to be able to protect it.
Okay, I think that's all we have. I just want to say thank you for your attendance, and if you have any additional questions, follow-up questions that we may not have addressed, our contact information, you know, it's there. I think our URL and also our Twitter account, so forth. So you could always reach out to us. Thank you very much.
Thanks, guys.